Well, I've got a few things done on the robot, and I just wanted to show you. This is from the kind of the big picture view here. Is we have our double stacked DC to DC converter here. There's one, and then down below is the other one down there. There are 7 to 12 volts in, 2 amps out supposedly. Although I still have that weird problem where when it drops to 7 volts, the amperage doubles. The LiPo battery is never going to go that low. It's only going to go to about 10.5 volts. So whatever power it supplies at 10.5 to 12.5 volts, that's just what it's going to supply. And if I need to put more in there, I will. Then there's Arduino. That's going to be the motor controller. It'll do a lot of other things now that I have these pins free, but it's going to be the motor controller. And then there's the brains behind that motor controller. And then here's the motor controller itself, which is this independent one that doesn't need to sit on top of like a shield on top of the Arduino. Here's my terminal blocks. This is going to be plus 12, ground, and then plus 5, and then I'll share the grounds between the two. And of course, here's the 2 motors for the wheels. Oh, my LiPo battery back here. Yeah, real smart way to do it is I've just got an L bracket that I mounted on here, and I'm using a tie wrap to hold the battery. I just can't figure out a better battery solution than that. I suppose I could get 2 L brackets, put them back to back, slip it in there, but I'm still going to tie wrap it. I mean, it's not like you can run a screw through one of these things to hold it down. But anyway, that is that's kind of the big picture of where we're at. What I'm doing now is just running the wires themselves. This is the input to the DC to DC converter. Here's, of course, the LiPo battery's outputs. And then here's the output, one of the outputs, 2 of the outputs from and I thought of combining the outputs of the DC to DC converter. I got away with it once before, and it actually worked. I don't know if it would. I don't know if it's going to work in this case. I don't know if I should try it, but I may have to try it off on the bench first to see if something like that would work. But it would simplify things. So I'm going to hook up all the wires, get the Arduino powered up, get the Arduino powered up, get the motor control board powered up, and then load up a sketch into the Arduino just to start running things around. I've got to get back to where I was before all this, but at least now I have a power solution, and I've got an Arduino that I can talk to from the ultrasonics, so the ultrasonics board. And I can't think of anything else with it. And I still need to test that power supply, but it is what it is. If it only gives out so much at 12 volts, it's still, between the two, it'll still give out a good 600 milliamperes. I think that'll be fine at the 5 volt level. The 12 volts will handle the motors, so I think we're going to be okay. The LiPo 12 volts from that's going to be directly connected to the motors, so I think we'll be alright with that. Okay, I'll be back shortly. See, now this is the kind of problems you run into. I've got this lug here that what my plan was to snip this off. This is the LiPo battery cable. This is negative. Snip that off, strip it, put that in there, crimp it down good. But look, this, let me get my fingers out of the way, that does not fit. It will not go in there. And I bought a whole box of those from Home Depot. I guessed it, I eyeballed it, and it didn't work. See, I should have taken down a terminal block with me and made sure that they fit. and so that doesn't fit. So that's not going to work. So this is the kind of frustration that you run into. Well, maybe it's those of us who don't think. Maybe it's me who doesn't think ahead to do that. That maybe that's our frustration. But anyway, this is the kind of frustration that you run into when you build a robot. It's all the little things. I mean, I just finished drilling 4 or 5 holes through this aluminum, and if I pull back and show you this aluminum, it's not thin aluminum. It's pretty thick aluminum. And I mean, I don't know what that is, 1/8 of an inch. I've got tools to measure, but I think, yeah, tools to measure. I have a ruler. It's pretty thick, and it takes a bit to drill through there. For me, anyway, it does. Some people are just used to doing that. But I had drilled holes for the battery, drilled holes for the DC to DC converter, drilled holes for the Arduino, put it all in, and then I don't have all the holes I want because I'm terrible at lining up holes. Getting holes aligned with each other is just, I don't know, I don't have a good solution. If I use a ruler and measure one hole from the other and then mark it on the aluminum plate, I'm always wrong. I'm always off. I can't seem to get that down. Maybe it's just, I mean, maybe you're just laughing at me right now. That's fine. I can't seem to go by measuring something and getting the hole in the right place so that I can put a screw through it and it fit. I'm always off. I'm always off, 1/16th, 1/8 of an inch, and that's enough to just ruin it. So what I end up doing is putting one down, mounting it, and then going and drilling the other hole as it sits there, if it allows me to do that. If it's an electronic board, I really can't do that because you'll affect the electronic board itself. You'll damage it. But if it's something like these terminal blocks, I can do that. I can mount those. Like I can put a screw in here, mount that good, and then go in here with a drill and actually drill a hole. That works fine for me. And I was just wondering if you all have a better solution than that. I mean, do you measure and it works good? You measure, 2.5 inches from here to here, and then 1/2 inch from the edge to here, and then that works perfectly for you? I mean, does that work? Because it doesn't work for me. So I really have to struggle. I have to fight at every level. I have to fight this. Now I got a box of these things that are now no good, at least for this application, because they don't fit in the terminal blocks. Now what am I going to do now? I'm going to go ahead and snip these because I'll go to Home Depot tomorrow and get another box, and I'll take a terminal block with me to make sure it fits. But I'm going to go ahead and snip these now, strip them, and just curl them around there and mount them in so that I can get the thing running. But anyway, I wanted to share that frustration with you, and I'll be back shortly. Well, to solve part of my problem, I'm going to order this off of eBay. You get 5 pieces for about $6, and I ordered 2 sets, so that'll give me 10 of these. And these are the barrel jacks that will go into the Arduino, so that I can wire up the Arduino itself, either with the well, I can't do the 5 volts coming out of the DC to DC. I'll have to up those. I can just adjust those up to say 7 volts, and then wire those into these barrel jacks that you're looking at. Plug those in the Arduino, and then we're looking at, I think, I can get better current out of them, and I can because I'll have 7 volts. I mean, not better current, better heat dissipation, because I'll only have 7 volts going into the Arduino instead of say 12 coming from the LiPo battery. And the other solution is going to be Home Depot, where I get the terminal lug that will fit the terminal block. And that was just a matter of me not carrying the terminal block down there and looking at it myself and measure it myself. But so that's what I'm going to get to. This will solve the Arduino thing. And between now and then, I can just adjust those DC to DC out, DC to DC converters, adjust those to 5 volts. And right here, you're not going to be able to see it, but I can show you at least the pin. You get a pointer. But right here, that pin, gosh, can you see that at all? I can't really on my small screen. But right there, the pin is the VN pin on the Arduino. And I can actually put the 5 volts directly in there and supply it. Of course, you have no protection with that. So if I put that in there, and this thing jumps to, it's probably got a, I'm sure it has a 5% tolerance. So it'll go to 5 1/4 or 4.85 up to 5 1/4, something like that. Or 4.75 to 5 1/4 would be standard tolerance. It might tolerate 5 1/2, but if it pops up to 7 volts, going directly into that VN pin that I just showed you, boom, I've just lost an Arduino chip, so an Arduino board. So that's kind of a dangerous way to go. I don't know if I'll do that, but I may have to, because I don't want to wait a week for these. See, these are the kinds of decisions you got to make in these cases, because you don't want anything to stop you from working. But on the other hand, you got to have these little gadgets to continue on. Anyway, we'll see. We'll continue with the saga here as we go. Thank you. Okay, you can see here where the battery, this is the LiPo battery positive terminal coming in, goes to the terminal block, and then goes to these 5 terminals within the terminal block via this jumper, special made jumper for it. So that gives me 5 outlets that I can tie to get 12 volts off of. And then there's the ground terminal of the LiPo battery, and same thing with it. So the first one is being used to go to the I know it's kind of hidden behind the motor control board, but this is the DC to DC converter. So that's where the first set goes, and then that will go to that's 5 volts. I've got 5 volts coming out of both of those. There's this double stacked, as I showed before, the double stacked DC to DC converters, and I've got both of them coming out here. And one of them is going to go to the Arduino just for a test. I want to test it to make sure that it's working good. Hope I don't blow up the Arduino. No, I shouldn't. The meters are showing 5 volts coming out of it, and I jiggle around the wires and whatnot, and I'm not getting anything, any variation in the output voltage. So I think it's pretty solid. So we'll try that. Well, I'm picking out the switch to be used as the main power switch for the robot, and I wanted to show you this. This is a Radio Shack. Back when they were in business, they sold, as they were going out of business, they sold these for, I think this one was like $10 for the whole box. So I bought, I think, 2 of them, 2 boxes, and you just got this variety of switches, and which is, you never know when you're going to need a switch. You need one for something like I do now. And I was looking around in there. I can pan over, and it looks like maybe the one I would want would be this one right here. This is F, which is single post, single throw, 6 amp, 125 volt. That sounds like 6 amps would be plenty. This thing's never going to see 6 amps going through it. This will go to the Arduinos and the power circuitry but won't go directly to the motors. So I think I'll use this one as the switch. Plus it's small enough, I have a drill bit that's small, or drill bit large enough that I'll be able to drill a hole in there and then, you know, mount it properly. And it's a nice little kit. They sold these. This is what I liked about Radio Shack. They sold all kinds of stuff that you just wouldn't find anywhere else. And you got big monster ones like that. I don't see me ever using that one, but you never know. Who knows? Some project, sometime, might need it. Now this one would also work, but I like this. I like the way this one feels a little better. This one here. I like the way it feels, and it'll mount nicely on there. So let's get that mounted. Well, I'm going to be using a different switch than the one I showed you before, because I'm going to switch the main. Instead of switching the 5 volts, I'm going to switch to 12 volts. And right now I'm at the back of the, here's the robot. There's the wheel, left wheel, right wheel, and down here's a switch. I've just brought it over to the soldering station because I didn't want to move the soldering station. But here's the switch on a third hand, and I'm going to have to bring this wire here, this red wire, down to the switch. Take it off of here, bring it down to the switch, you know, one of these terminals here, and then bring this black wire, which is a nice thick one, off the other side of the switch, and then back onto the terminal block, thus making the break. This is more of a standard looking switch, or you know, one we're used to. It's got the on off, it's got the big, let's see, and it was in that switch pack that I showed you. And this one, I don't have a drill large enough to drill through the aluminum to mount it, so I'm not quite sure how I'm going to mount this thing, unless I just mount it in mid-air, or you know, let it dangle in mid-air. That's the only thing I can think of for now, till I get a drill large enough to drill through that aluminum plate. And I just don't have the drill big enough for it that can handle that, hold that size. So anyway, that's what I'll do, and I'll just tape it up for now, and it'll be kind of a rig, but that'll do for now. So let me do that. I'm gonna, one thing I wanted to show you was this tool here. This is a stripper tool, but boy, these are nice. These are really nice stripper tools. And you take the wire and you put it in about where you want to strip, bring down, and then there, boom, you got your nice stripped wire, and you haven't cut any of that. One was already pre-stripped at this end, and you haven't cut anything, and those are not sharp. Those edges in there are not sharp, but yet it strips the wire perfectly, and I just thought I'd show you that. I got that at Fry's Electronics, but that's Fry's is not in very many cities, but you can order it, and I think it's about $20 for the tool, and it has been worth every penny because of the ease of which you can strip wires with it of any length. Any length stripping section that you want. Anyway, that's where we're gonna do, and I hope my soldering iron has enough heat capacity to do these large wires to that switch. That's what I'm hoping for now, but let me get that done and I'll be back.